Hello everyone. Here I am going to solve GATE Engineering Mathematics questions of the year 2020 for all branches. My videos covered all branches questions. In this video, the questions are related to calculus topic, in particularly maxima and minima concept. I already upload the concept video. If you want to learn the concept, then you have to watch. I gave the concept video link in the description box. Now let's move on to the problem. The first problem is for the function f of x equal to one function is given where lambda value also given. Sigma and mu are constants. The maximum occurs at what point? You have to find the value of the point. This question is from AE department. It has 1 mark. Here the function f of x is given. F of x equal to e power minus lambda. Lambda is also given. That is 1 by 2 sigma square x minus mu whole square divided by sigma into root 2 pi. Here sigma and mu are constants. Now next I am going to explain one theorem. That theorem is if f has a local maximum or minimum at C and if f dash of C exists, then f dash of C equal to 0. That means f dash of x equal to 0 at one point, then the function has local maximum or minimum at that point. So in that place I have to find f dash of x and equate f dash of x equal to 0. I got one point. That point makes maximum, local maximum or local minimum. So I find f dash of x. E power minus x differentiation is minus e power minus x, that is 1 by 2 sigma square x minus mu whole square divided by sigma root 2 pi is constant, and the differentiation of that part is 1 by 2 sigma square 2 into x minus mu into 1. X differentiation is 1. So finally I got these values are cancelled and minus e power minus 1 by 2 sigma square x minus mu whole square divided by sigma square into sigma, sigma cube root 2 pi x minus mu. This is the f dash of x value. Now I equate f dash of x equal to 0 and find the value of x. At that point the f has maximum or minimum point, the minimum value, maximum and minimum value. So f dash of x equal to 0, when put x equal to mu, then only the value of f dash of x equal to 0. So f dash of x equal to 0 only when x equal to mu. Put x equal to mu, we got the f dash of x value equal to 0. This is the only condition. So at x equal to mu, I got f dash of x equal to 0. So the maximum occurs at x equal to mu only. This is the final answer. Answer is D. The second problem is the function f of x equal to one function is given has a maxima or minima at x equal to 0 and maxima or minima at x equal to 1. You have to find what option is the correct answer. This question is from AG department. It has 1 mark. Here f of x is given. First I find f dash of x and I solve the equation f dash of x equal to 0. I got some points of x. That points are called critical points. At that point then function f has a local maximum or local minimum. So first I find f dash of x. 4x cube minus 12x square plus 12x minus 4. This is the differentiation of this function f. Now I equate the equation f dash of x equal to 0. I got x equal to 1 is the only one root. So in this case x equal to 1 is a only one critical point. Maximum or minimum occurs at x equal to 1. Okay, next I find it is maxima or minima. So in this problem the second derivative test fails because suppose I find f double dash of one value, I got the value 0. In this case we can't use second derivative method test. Okay, so in this problem I use first derivative test. What is the first derivative test? Suppose that C is a critical number of a continuous function f, then If f dash changes from positive to negative at C, then f has a local maximum at C. And if f dash changes from negative to positive at C, then f has a local minimum at C. Here x equal to 1 is a critical number and f is a continuous function. So I find f dash changes what, positive to negative or negative to positive. Here x equal to 1 is a critical point. First I take the interval x less than 1. X less than 1, all the values of x less than 1, I write this is x cube minus 3x square, take it 4 outside, 3x minus 1, and I write 4 into x minus 1 into x minus 1 into x minus 1. This is the factorization of this f dash of x. I substitute the value of, suppose if x is less than 1, x is less than 1 is 0 and negative values of x. Okay, so I got this is negative, this is negative, negative. 3 multiplication of negative also negative. So f dash of x is negative all the values of x less than 1. And next condition is x greater than 1, that means 1 less than x. Okay, 1 less than x, this is gives f dash of x is x greater than 1 means 2 3 etc. I substitute all the positive values. I got this is positive, this is positive, this is positive, because all the x are greater than 1 only. So multiplication of 3 positive also positive, f dash of x is positive all the values of x greater than 1. So f dash changes from negative to positive. So f has a negative to positive. What condition? F has a local minimum. Local minimum at x equal to c. C is here 1. So f of x has a local minimum at x equal to c. The answer is x equal to 1. Answer is option D. Option D is the correct answer. Now the third problem is a function f is given as f of x equal to 4x minus x square. The function f is maximized when x is equal to what? This question is from BT department. It has 2 marks. First I find the f dash of x and I find the critical point. F dash of x equal to 4 minus 2x. F dash of x equal to 0 gives the critical point. 4 minus 2x equal to 0. So 2x equal to 4, x equal to 2. X equal to 2 is the critical point. The function f is maximized or minimized at x equal to 2. You have to check it is maximized or minimized. Here I use the second derivative test. That is, second derivative test is, next I find f double dash of x. F double dash of x is minus 2. F double dash of x is always negative for all values of x. So f has a maximum at x equal to 2, because f double dash of x got the negative values less than 0. So f has a maximum at x equal to 2. So final answer is 2. Fourth problem is the maximum value of the function f of x. One function is given in the interval also given 0.5 comma 3.5 is, you have to find the maximum value of the function. This question is from CH department. It has 2 marks. First I find the f dash of x. This is equal to 3x square is the differentiation of x cube. So I got 3 cancel, minus 5x square plus 20x minus 15. Next, f dash of x equal to 0 gives, I solve this quadratic equation. I got two values 1 and 3. This is the critical points. These 2 points are lies inside the interval 0.5 and 3.5, which are lies inside the interval 0.5 comma 3.5. The end points are 0.5 and 3.5. Now I find all the values of f at x equal to 1 and x equal to 3 and 0.5 and 3.5. Critical points, value of x at critical points and end points. Now I substitute 0.5. I got, first point is 0.5. I substitute the value of x 0.5 in f of x. I got 10 point something 792. and I substitute f of 1, I got 9.3 something. F of 3, 16, and f of 3.5, I got 14.542. The maximum value of the function f is 16. So the answer is 16. Option C is the correct answer. Option C is the correct answer. Now the fifth problem is for real number x and y with y equal to 3x square plus 3x plus 1. The maximum and minimum value of y for the interval minus 2 comma 0 are respectively. This question is from EE department. It has 2 mark. Now I find y dash, first derivative y dash equal to 6x plus 3. I solve y dash equal to 0, y dash of x equal to 0. Y dash of x equal to 0 gives x equal to minus 1 by 2. Minus 1 by 2 is a critical point. The end points are minus 2 comma 0. Minus 1 by 2 also lies inside the interval. So next I find all the values of y at the point minus 1 by 2, minus 2, 0. Critical point and the end points. The values of y, I find the values of y at the end points and critical points. Y of 0 equal to 1. Substitute the value 1 by 1. Y of 0 equal to 1. Y of minus 1 by 2 equal to 1 by 4. And y of minus 2, here minus 2 endpoints, minus 2 equal to 7. What is the maximum value? This is maximum value of y, minimum value 1 by 4. So maximum is 7, maximum and minimum value respectively. Okay, maximum is 7 and minimum is 1 by 4. So answer is option A. Option A is the correct answer. Sixth problem, consider the function f of x comma y equal to x square plus y square. The minimum value of the function attains on the line x plus y equal to 1 is dash. This question is from IN department. It has 2 mark. Here one subject to the constraint, one condition is given. So in that case, I use Lagrange multipliers method. That is, the method is here to find the maximum and minimum values of f of x, y, z. 3 variable function also given. Here 2 variable function is given. F of x comma y comma z subject to the constraint is g of x comma y comma z equal to k. Assuming that these extreme values exist at del g not equal to 0. Del means gradient of g not equal to 0 on the surface g. Find all the value. Procedure is I have to explain procedure. Find all the values of x, y, z and lambda such that the condition is del f equal to lambda del g. Del is gradient of f equal to lambda into gradient of g, and using that subject to the constraint g equal to k. So second step is evaluate f at all the points x, y, z. The result from step A, the largest of these values is the maximum values, is the maximum value of f. The smallest is the minimum value of f. Okay, this is the procedure. So here f of x comma y is x square plus y square, and g of x comma y equal to x plus y. This is equal to k. X plus y equal to k. The first step is equating the equation del f equal to lambda del g. What is del f? Gradient of f. That is dou f by dou x into I vector. That is 2x I vector plus dou f by dou y into j vector, 2y j vector. This is equal to lambda into dou f by dou g by dou x I vector. That is 1 I vector. Dou g by dou y j vector. That is 1 j vector. And here I use the g of x comma y equal to k, also x plus y equal to 1. Equating these two vectors, I got 2x equal to lambda and 2y also lambda. This gives x equal to lambda by 2 and y is also lambda by 2. Substitute the x and y value in the subject to the constraint. I got lambda by 2 plus lambda by 2 equal to 1. That is 1 lambda equal to 1. Finally, I got lambda value is 1. I substitute the lambda value in x. I got x equal to 1 by 2 and y equal to 1 by 2. Therefore, I got the point 1 by 2 comma 1 by 2. Therefore, f has possible extreme values, that is maximum or minimum, possible extreme values at the point 1 by 2 comma 1 by 2. Here one point is available, so this is the minimum value of the function. F has possible extreme values at the point 1 by 2 comma 1 by 2. What is that value? F of 1 by 2 comma 1 by 2. Substitute the value of x and y in f of x comma y. I got 1 by 4 plus 1 by 4. This is equal to 2 by 4, that is 1 by 2. So the final answer is 0.5. 1 by 2 is 0.5. This is the final answer. Seventh problem. For x in the range minus 3 comma 3, the maximum value for the function is, here one function is given, this is the maximum value. I find the maximum value of this function. This question is from MN department. It has 1 mark. First I find the f dash of x and I find the critical point. This is 3x square minus 12x plus 9. Here 3 is common, take it outside, x square minus 4x plus 3. F dash of x equal to 0 gives, I solve this quadratic equation, I got 2 points, that is x equal to 1 comma 3. These are the critical points. Critical points are stationary points, extra. Okay, so these points are lies inside the interval. So the end points are minus 3 comma 3. These points are lies inside the interval. Here closed interval is given, so 3 also here. So next I find the maximum or minimum value of the function. I substitute the value, the points 1 by 1 in the f function. I got f of minus 3 equal to minus 93 and f of 1 equal to 19, f of 1 equal to 19, f of 3 equal to 15. So the maximum value is 19. The maximum value of f is 19. Answer is 19. Eighth problem is f of x, one function is given, has maxima, local maximum or local minimum, etc. at x equal to 0.5. The point is given. You have to find it is local maxima or minimum or point of inflection or non-zero slope. This question is from MT department. It has 2 mark. First, I find f dash of x. Here, the point given. So, I do not find the critical point. But I have to check it is local maximum or minimum or point of inflection, etc. So, I find f dash of x. In that place, I use second derivative test. So, first I find the f dash of x. What is f dash of x? Here uv, formula of uv, d of uv is u into dv, that is x into 1 by x plus v into du. This is 1, du is 1. Next, differentiation of this term, u into 1 minus x into log of 1 minus x is 1 minus x into minus 1. Here 1 minus x differentiation is minus 1. Next, this v, log of 1 minus x and 1 minus x differentiation is minus 1. 1 minus x differentiation is minus 1 plus 3x, so I got 3 and 3 minus 3x square, so I got minus 6x. In this case, cancel 1 plus log x, 1 minus x cancel, I got minus 1. Here minus of log of 1 minus x plus 3 minus 6x. So 1 minus 1 cancel, log x, log of 1 minus x plus 3. So log x minus log of 1 minus x plus 3 minus 6x. Next, I find the second derivative because here I use second derivative method. Suppose if double dash is continuous near C, if f dash of c equal to 0 and f double dash of c greater than 0, then f has a local minimum at C. F dash of c equal to 0 and f double dash of c less than 0. Here this is wrong. less than 0, then f has a local maximum at C. Local maximum at C. Okay. Next, I find f double dash of x. Double dash of x is log x is 1 by x minus log of 1 minus x is 1 by 1 minus x into minus 1. So this is plus. This is 0 and minus 6. I put x equal to 0.5. You have to find x equal to 0.5 only. So I put in the second derivative 0.5. F dash of 0.5 equal to, this is 2, 1 by 2, this is 2. 1 by 1 minus 2 also 1 by 2 plus 2 minus 6. Finally, I got negative 2. Minus 2, this is less than 0. So less than 0, f has a local maximum at C. Here C is 0.5. So less than 0, f has a local maximum at x equal to 0.5. So answer is B. Correct answer is option B. Ninth problem, the number of points at which the function, here number of points, f of x comma y, two variable function is given, has local minima is. Here you have to find the function f has local minima at what are the points. Okay, you have to find what are the points has the local minima. So this question is from XC department, it has 1 mark. Here two variable function is given. So the result is second derivative test in two variable is, suppose the second partial derivatives of f are continuous on a disk with center a comma b, and suppose that fx equal to 0 and fy equal to 0. We got the reflection critical points or inflection points. Let d equal to fxx into foy minus fxy whole square. Suppose if d greater than 0 and f x is also greater than 0, then f of a comma b is a local minimum. Second condition is if d greater than 0 and fxx is less than 0, then f is local maximum. F of a comma b is local maximum. If d less than 0, then f of a comma b is not a local maximum or minimum. So here I use this second derivative test. Okay. First I find fx equal to 2x by 2, so x. Next fy, this is 4y cube by 4, so y cube minus 2y by 2 y cube minus y. Fx equal to 0 gives x equal to 0 and fy equal to 0 gives y into y square minus 1 equal to 0, that is y equal to 0 and y square equal to 1, y equal to plus or minus 1. So the critical points or inflection points are 0, 0, 0, 1, 0, minus 1. Next I find the d values at the point, these 3 points. First, what is d? D is fxx, fyy minus fxy whole square. So I find fxx, here I find fxx equal to 1, fyy equal to 3y square minus 1, 3y square minus 1. fxy, partially differentiate fx with y, at y has 0, fxy equal to 0. So d of x comma y, first I find d of x comma y and I substitute the points one by one. D of x comma y equal to fxx into fy, that is 3y square minus 1 minus 0. So this is the d of x comma y. First I substitute the point d 0 comma 0, d of 0 comma 0 equal to minus 1. This is less than 0, so that point is not a local maximum or minimum. F of 0 comma 0 is not a local maximum or minimum. Next, d of 0 comma 1. I got 3 minus 1, 2. This is greater than 0. So D is greater than 0. I have to check fxx is what? Fxx is always greater than 0. 1. Fxx is 1. This is always greater than 0. So greater than 0, then f of a comma b is a local minimum. This point is a local minimum point. Local minimum. Okay, next d of 0 comma minus 1 also 2. This is greater than 0. Fxx is always greater than 0. This is also minimum. So 2 points has the local minima values, that is 0 comma 1 and 0 comma minus 1. These 2 points has the local minima values of f. Okay, so the answer is 2. Final answer is 2. 10th problem is consider the functions. 1, 2, 3. 3 function is given. Which of the above function is are increasing everywhere? Increasing everywhere in interval 0 comma 1. This question is from CS department. It has 1 mark. First I check the function e power minus x. Statement 1. F of x equal to e power minus x. Here I use the increasing decreasing test. That is, if f dash of x greater than 0 on an interval, then f is increasing on that interval. If f dash of x less than 0 on an interval, then f is decreasing on that interval. All the values in the interval. Okay, this is important. This is increasing decreasing test. First I find the f dash of x. F dash of x equal to minus e power minus x. This is always decreasing function. Why? Because e is always greater than 0. E value is 2 power 7, 2.718. 2.718. So e power x is always greater than 0. E power x is always greater than 0 in the interval 0 comma 1. So e power minus x always greater than 0. E power minus x means 1 by e power x. This is positive value only. So e power minus x is greater than 0. But minus e power minus x is less than 0. Multiply one minus sign, we got less than 0. So f dash of x is negative. F dash of x is negative, always negative. So f dash of x is negative in the interval 0 comma 1. So f is always decreasing function. In statement 1, the first function is f is always decreasing function. Decreasing function. Next, second one is x square minus sin x. F of x equal to x square minus sin x. F dash of x equal to 2x minus cos x. Here the interval is 0 comma 1. First I substitute the point 1. I got f dash of point 1 is f dash of, this is dash not double dash, f dash of point 1 is negative. I substitute the value, another one value in the interval f dash of 0.5. This is positive. Here one sign change is here available. In this place f has a stationary point. F has a stationary point. This is the first derivative test. Okay. Suppose f is f dash changes negative to positive, then it has a local maxima or minima. I don't know. Okay. So this is, it has the function, the f has in that interval 0 comma 1 one stationary point. One stationary point. So f of x has a stationary point in the interval 0 comma 1. So it is not always increasing. It is not everywhere increasing everywhere. That is not always increasing. Next, third is f of x equal to root of x cube plus 1. F dash of x equal to root of x cube means whole power 1 by 2. 1 by 2 into whole power minus 1 by 2, that is root of x cube plus 1. 1 by root of x cube plus 1. And differentiation of x cube plus 1 is 3x square. This is the f dash of x. 3x square. Now I substitute the values in that interval. This f dash of x is always positive because this is x cube and square root x cube. Okay, so 3x square, this value is also positive, this value is also positive. So f dash of x is greater than 0, the positive, greater than 0, not greater than 0. F dash of x is positive in all values of x interval 0 comma 1. F of x is positive, f dash of x is positive, so f of x is always increasing, that means increasing everywhere in the interval 0 comma 1. So first one is always decreasing function, so this is not the answer. Next, second one is not always increasing. Okay, third one is only f of x is always increasing in that interval 0 comma 1. That means increasing everywhere in the interval 0 comma 1 is third only. Third means option A. Answer is option A. Answer is option A. These are the GATE 2020 engineering mathematics questions related to the concept maxima and minima. If you have any doubt in this topic, then you can ask in the comment section. Let me try to clarify your doubts. Thank you. See you in the next video. If you like this video, please like, share and subscribe my channel to encourage me. Thank you.